Welcome back. In the last video, we wrote some code here to save our PyTorch model. I'm just going to X out of this, a couple of things that we don't need just to clear up the screen. And now we've got our .pth file, because remember, .pth or .pt is a common convention for saving a PyTorch model. We've got it saved there, and we didn't necessarily have to write all of this path style code, but this is just handy for later on if we wanted to functionize this and create it in, say, a save.py file over here, so that we could just call our save function and pass it in a file path where we want it to save, like a directory and a name, and then it'll save it exactly how we want it for later on. But now we've got a saved model, I issued a challenge of trying to load that model in. So do we have torch.load in here? Did you try that out? We've got a few options here. Wonderful, but we're using one of the first ones. So let's go back up here. If we wanted to check the documentation for torch.load, we've got this option here, load. What happens? Loads an object saved with torch.save from a file. Torch.load uses Python's unpickling facilities, but treats storages which underlie tensors specially. They are first deserialized on the CPU and then are moved to the device they were saved from. Wonderful. So this is moved to the device. If later on when we're using a GPU, this is just something to keep in mind. We'll see that when we start to use a CPU and a GPU. But for now, let's practice using the torch.load method and see how we can do it. So we'll come back here and we'll go loading a PyTorch model. And since just going to start writing here, since we saved our model's state dict, so just the dictionary of parameters from a model, rather than the entire model, we'll create a new instance of our model class and load the state dict. Load the saved state dict, that's better, state dict, into that. Now, this is just words on a page. Let's see this in action. So to load in a state dict, which is what we saved, we didn't save the entire model itself, which is one option. That's extra curriculum. But we saved just the model state dict. So if we remind ourselves what model 0.stateDict looks like, we saved just this. So to load this in, we have to instantiate a new class or a new instance of our linear regression model class. So to load in a saved state dict, we have to instantiate a new instance of our model class. So let's call this loaded model 0. I like that. That way we can differentiate because it's still going to be the same parameters as model 0, but this way we know that this instance is the loaded version, not just the version we've been training before. So we'll create a new version of it here, linear regression model. This is just the code that we wrote above, linear regression model, and then we're going to load the saved state dict of model 0. And so this will update the new instance with updated parameters. So let's just check before we load it. We haven't written any code to actually load anything. What does loaded model 0, what does the state dict look like here? It won't have anything. It'll be initialized with what? Oh, loaded. That's what I called it. Loaded. See how it's initialized with random parameters? So essentially all we're doing when we load a state dictionary into our new instance of our model is that we're going, hey, take the saved state dict from this model and plug it into this. So let's see what happens when we do that. So loaded model 0. Remember how I said there's a method to also be aware of up here, which is torch nn-module.load state dict. And because our model is a what? It's a subclass of torch.nn.module, so we can call load state dict on our model directly, or on our instance. So recall, linear regression model is a subclass of nn.module. So let's call in load state dict, and this is where we call the torch.load method. And then we pass it the model save path. Is that what we called it? Because torch.load, it takes in f. So what's f? A file like object. or a string or an OS path-like object. So that's why we created this path-like object up here, model save path. So all we're doing here, we're creating a new instance, linear regression model, which is a subclass of nn.module. And then on that instance, we're calling in load state dict of torch.load model save path, because what's saved at the model save path? Our previous model's state dict, which is here. So if we run this, let's see what happens. All keys match successfully. That is beautiful. And so see the values here? Loaded state dict of model 0. Well, let's check the loaded version of that. We now have, wonderful, we have the exact same values as above, but there's a little way that we can test this. So how about we go make some predictions? So make some predictions just to make sure with our loaded model. So let's put it in eval mode, because when you make predictions, you want it in evaluation mode, so it goes a little bit faster. And we want to also use inference mode. So with torch.inference mode for making predictions, we want to write this, loaded model preds. We're going to make some predictions on the test data as well. So loaded model 0, we're going to forward pass on the X test data, and then we can have a look at the loaded model preds. Wonderful. And then to see if the two models are the same, we can compare loaded model preds with original model preds. So y preds, these should be equivalent. Equals loaded model preds. Do we have the same thing? False, false, false. What's going on here? Y preds. How much different are they? Oh, where's that happened? Have we made some model preds with this yet? So how about we make some model preds? This is troubleshooting on the fly, team. So let's go model 0.eval, and then with torch.inference mode, this is how we can check to see that our two models are actually equivalent. ypreds equals, I have a feeling ypreds actually saved somewhere else, equals model 0, and then we pass it the X test data. And then we might move this above here, and then have a look at what ypreds equals. Do we get the same output? Yes, we should. Wonderful. Okay, beautiful. So now we've covered saving and loading models, or specifically saving the model's state dict. So we saved it here with this code, and then we loaded it back in with load state dict plus torch load, and then we checked to see by testing equivalence of the predictions of each of our models. So the original one that we trained here, model 0, and the loaded version of it here. So that's saving and loading a model in PyTorch. There are a few more things that we could cover, but I'm going to leave that for extra curriculum. We've covered the two main things, or the three main things, 1, 2, 3. If you'd like to read more, I'd highly encourage you to go through and read this tutorial here. But with that being said, we've covered a fair bit of ground over the last few videos. How about we do a few videos where we put everything together, just to reiterate what we've done. I think that'll be good practice. I'll see you in the next video.